All right, so we are ready for 13.7. A couple of units left, 13.7, 13.8. Schedule for the week is 13.7 today, 13.8 tomorrow. Quiz on Wednesday, chapter review on Thursday, and your test will come on Friday. So it's just around the corner. Test on Friday, and that's been on InfoDirect since Thursday last week. So if you've been on, you knew that that's coming, and that's the way things will work. All right, so we've gone through our area, and you don't want to forget area. You can't do that. You've got to know the formulas to be able to perform area. So be careful there. Be careful, be careful, be careful. You got to know the formulas. And then now we get into the aspect of volume. And a Rubik's Cube is a great example for thinking about volume. So Rubik's Cube works real well. And a volume is what involves three dimensions, right? Volume is in 3D. 3 dimensions with volume. So you've got length times width times height. What's the matter, Jack? Yes, I am recording. Oh, my board is frozen. I'm actually recording. You guys aren't seeing is what it is. All right, I'm frozen. Yeah, I am recording now, but thank you. All right, so 3 dimensions for volume, and you've got to keep that in mind. If you've ever done a Rubik's Cube, so how many cubic units are there in that Rubik's Cube? How many cubic units? How many little squares make up that Rubik's Cube? How many squares, Sam? No. A whole lot more. Alexandra? 54. Not that many. John? No. All right. This is interesting. Yes, Wyatt. There are 27 little squares that make up that Rubik's Cube. All right. So the volume of a cube, and what we mean by a cube is the length is the same as the width is the same as the height. So look at the length here. Can you see it's 3 units long? Right? 1, 2, 3, right? What's the width? 3 units long, right? 1, 2, 3. And what's the height? 3 units long, right? 1, 2, 3. It's a cube. How can you figure out the volume? 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27 cubic units, right? 27 cubic units. Think about this bottom row of the Rubik's Cube. You've got 3 here, 3 more in the middle, and 3 more in the back, right? You got 9. So you got 9 little cubes on the bottom level, another 9 in the middle level, now we're up to 18, and another 9 on the top level, now we're up to 27. So I don't know how you're getting to 54 or anything else, but there are 27 little cubes that make up a Rubik's Cube. And therefore the volume of that Rubik's Cube is 27 cubic units. So cubic units, length times width times height for a cube. Jordan.
The length and the height the same?
For a cube, for it to be a cube, the length, width, and height are all the same. That is what a cube is. The length, the width, and the height are all the same. If that's not the case, it's not a cube. Only cubes are shapes where the length, the width, and the height are all the same. Okay? Units for any kind of volume, not just cubes. Units for any kind of volumes, feet cubed, right? Inches cubed. Centimeters cubed. Meters cubed. Kilometers cubed. You can go acres cubed if you want. You can go yards cubed if you want. You could go furlongs cubed if you want. You watch the Kentucky Derby, they mention furlongs. All right, it's just a different measure there. You could go miles cubed. If you were talking about the New Jerusalem, we'd talk about miles cubed. All right, cubic units, not a big deal. Pretty simplistic. All right, let's start working our way through our formulas here. All right, so you got the formula's already done for you, nothing to fill in. Volume of a prism or a cylinder. Area of the base times the height. All right, so what does that formula mean? It means you got to take the area of the base and you got to multiply it times the height. But here's the question in all this, and here's the key. Different prisms or cylinders have different bases. They have different bases. Ah, you are here. So for a, let me go to this page. I'll come back in a minute. Oh, did I have them down there at the bottom? Let me see. Let's get rid of these. Yeah, okay. So you can see these are all, that the left one's a cylinder, right? This one here is a cylinder. This is a prism, and this is a prism. You can have all kinds of different shapes on your prisms. So the formula is going to change. The specific formula is going to involve that formula that you have for a base. So let me see if I can go through this. So here's the general formula, right? The volume of any prism or any cylinder is area of the base times the height. However, you have to take note of what kind of base you have, and that's what's going to go in place for the area of the base. So let's go through. You guys know these. So I'm going to ask what the formula is. You raise your hand and tell me. So if you had a parallelogram for the base of your prism, what formula would you use for area of a parallelogram? Jack? Base times height, right? Because that is the formula for area of a parallelogram. So if you were doing a cylinder that had a parallelogram for a base, that's what you would put in place of area of the base. What if you had a trapezoid for a base of your prism? What formula would you use? Andrew? Not quite. Got the half right. Ashton? Correct. 1/2 times the quantity, base 1 plus base 2 times the height. That's what you would use there if you had a trapezoid for a base. What about area of a triangle? What is the formula for area of a triangle? All right, Andrew, go ahead. 1/2 base times height. Actually, I went out of order by my numbers. So 1/2 base times height is what the formula is for area of a triangle. And then what about area of a circle? Area of a circle. Sam? Actually, they're round, but pi r squared works for the formula. Pi r squared. And again, that's what would go in for the area of the base. So again, you got to take note of what kind of shape do I have. So how do you start off a volume of a prism or cylinder? Start with the main formula. Volume of prism or volume of cylinder equals area of the base times the height. And then you continue from there. Now, I will tell you this. Your book, and some books like to do this. Jack, put your hand down for a moment. I'm talking. I see it. It's just a distraction. So sometimes you're going to see, instead of writing area of the base like this, they put just a capital B. That's their notation. I don't think it's best. If I could change all Mathendon and get them to change it to capital A subscript base, I would. But unfortunately, a lot of them like a capital B. So please note that's the same way of saying area of the base. You guys got that? So again, every once in a while you'll see a capital B times H. They expect you to know that the capital B means area of the base. All right, so just be prepared that that's a possibility in the midst of seeing that formula for volume. Jack. The area of the base is base times height. To get the volume, you'll have to multiply that value times the height of the whole shape. And you'll see that in a little bit when we get to our examples. Okay, so just like we learned with area, height is always perpendicular. In this case, it's the perpendicular distance between the bases. Prisms and cylinders have two bases. So in the left cylinder, the height would be right here. It would be this distance, right? The perpendicular distance between the bases. Now, they didn't shade the top, but, oops, I wanted that to be red. You know, we could color in that top, right? Cylinder has two bases. And the height is the perpendicular distance, put it higher for you guys, between those two bases. Now, prisms are kind of funny because you can rotate it, right? I mean, this is a prism. So right now, I'd call this the base and this the base. And then the height would be this distance right here, right? Well, what if it's sitting like this? That's okay. You can call this the base and this the base and multiply it times this height. Be fine. It'd be the same answer, by the way. Would the volume change whether the box is up like this or down like that? No. Volume doesn't change. Or it could sit like this. And this could be the base, and this could be the base, and then this would be the height. Prisms are that way. They've got a lot of different parallel sides. For our illustration, we've got it sitting on the base. So this would be the other base right here, right? The top of it. And the height would be right here, right? That perpendicular distance between the two bases. And then the last one, the triangular prism. You know, the other base is up there. And by the way, for a triangular prism, that's the only way it could work. Those are the only bases. Because the other three sides are not parallel to each other. And of course, the height would be this value right there, right? The perpendicular distance between the two bases. All right? So volume of prisms, and volume of cylinders. Problems aren't hard. All right, so I got the formula up there on top for you again, and we're going to start working on figuring out the volume of our shapes. So somebody raise your hand. How do you start a problem like this? Gabe?
A equals area of a circle times area of a rectangle.
Okay, not quite. On this, I would go volume, and I'd go CYL, right? I picked which one. Is it a prism? Is it a cylinder? It's a cylinder, right? So I went volume of a cylinder. And Gabe said area of a circle for the base. I agree, right? Do you agree it's an area of a circle? And then I got to multiply, though, times h. I'm just keeping my colors so we can figure things out. All right. It is wise to take one more second and now substitute in the proper area formula. So, Austin, what formula do we put in for area of a circle? Pi r squared. So that's going to go in red, right? That's our area of a circle times our green height. Is everybody okay with that? That makes sense, right? We're just, and look, be orderly like this. You know, as you get more and more complicated with shapes, your orderliness really matters. And remember, a lot of times we're going to try to show you things on more simplistic things. So don't think, oh, it's so easy. I don't need to write the formula in. It's easy. Well, no, you need to begin to learn the procedure so you can do the harder things. And it just takes a second. You know, we started with area of a circle, and now we're to pi r squared. And now we're ready to put in our values, right? All right, why don't you try to finish it? Go ahead and finish it from there. I'm going to pause the recording, so you might want to do that as well if you're working at home, and then you can restart it when you're ready to give the answer. The majority of you are in the ballpark. So on three, give me your answer. Here we go. 1, 2, 3.
1017.36
Feet cubed. And you know what? I didn't even bother to look. That thing does end, doesn't it? You guys are better. I would put the 0.36. I agree. I didn't even bother to look. I'm so used to rounding. All right. 1017.36 feet cubed. You've got feet squared from right here and another feet there, right? Feet times feet times feet is a whole lot more stink. All right. Feet cubed. 3-footed monster would have awfully smelly feet. All right. Hey, that's not too hard. Questions on that? Any questions on that? Hey, John, can you grab that door for me? Yes, Connor? Speak a little louder for me. No, we're really not finding area at all, Connor. We're really trying to figure out how many foot by foot by foot cubes fit inside that shape. That's what we're trying to figure out. So we're doing it mathematically. And the way to get it is, if you know the area of your base and you multiply it times your height, it'll tell you how many of those cubes you can fit into that shape. So that was a good question, because that's the whole concept of what we're trying to do. How many foot by foot by foot cubes can fit inside there? And again, mathematically, we can figure out the pieces. You know, if I had a bunch of baby blocks, you know, ABC blocks, and I had a cylinder, I mean, we could stick the blocks in there and see how many we got in there. Now, we'd never be able to get the complete volume, right? Because the box, we'd have to be cutting cubes up to get them in there. But mathematically, we're figuring out the exact mathematical amount that would fit in there. Jack? I didn't round because it ended. So 1017.36 is the answer, because that ended in 2 decimal places, and so we should end as well. All right, so here's a prism. So again, we're going to start the same way. Volume of a prism equals, somebody raise your hand and tell me what formula to use for area of the base. Area of the base formula. Jordan? It is an area of a rectangle. You could also use area of a parallelogram, but that is a rectangle. If they don't tell you you have a right angle and they don't show you any height, then you assume it's at a right angle. Okay? That is a rectangle. And then my green times the height, the whole shape. Now use your color here, because watch what's going to happen. Use your color. All right, so what is the formula for area of a rectangle? Gabe? All right, so in red, I'm going base times height. But then notice in green, I have another h, right? Another height. I have 2 heights. Now, the color makes it easy, but be careful. The first height is the height of the base. The second height is the height of the prism, right? They're different. So let's go ahead and substitute in. Somebody tell me, what should I put in for the base? For the base, Raquel? 5 whats? I always include my units, and if I do, I'll never forget them. All right, what is the red h? Somebody give me the red h. Adam? That is 7 centimeters. And therefore, then, what is our green? Blake? Then 10 centimeters is the height of the whole prism. So just punch that out on your calculator, or do it in your head. 5 times 7 is 35 times 10 is 350. 350 centimeters cubed. So in that prism, that size, if you had a centimeter by a centimeter by a centimeter cube, you could fit 350 of them in there. Fit 350 of them in there. of centimeters cubed. That's what we're trying to figure out. How many three-dimensional cubes fit in a shape? That's what we're after. All right, here's a prism. By the way, I'm helping you guys out in the notes, and I'm telling you what shape it is. But on a quiz or a test, you'd have to know that that's a prism. You know, you'd have to know that, so be careful. A prism is a polygon for the bases, and it's three-dimensional. Okay, so formula, volume of a prism. Area of the base. What kind of base? Again, raise your hand. What kind of base do we have here? Looking for somebody new. Lauren? It is a triangle. All right, great. This is right here is the first base, and the other side is in there, right? Three-dimensional, trying to get the look of that thing. So it is area of the base, area of a triangle times the height. So you're just working your way through the problem. You're nice and orderly. Kyle, what kind of formula do you want to put for area of a triangle? Good. You didn't forget the half. 1/2 base times height. That stays in red. And notice again we have two heights, right? The height of the base and the height of the shape. All right, well, a half is a half. What is the base value of the triangle? Pamela? It is 4 meters. Now this example is a nice example. Why is it nice? Because it really doesn't have extra numbers. So somebody tell me what the height is of our triangular base. Kaylin? It is 5 meters. Oops, that should be red. Now take a look at the prism on the screen. Look, sometimes they're going to have numbers here, and I don't know what they are. I'm just going to write it. You don't need to write this, but sometimes there'll be a 10 centimeters there and a 10 centimeters there. And do you realize we don't need those numbers, and we're not going to use those numbers. They might be there. So how do you know which ones to use? Well, remember, you choose the base that goes with the height that they gave you, right? That height is perpendicular to the 4, and therefore the 4 would be the base. Is it always going to sit on the base of the triangle? No, not necessarily. Not necessarily. So you just got to look. You got to look at each one. You already know how to do area of a triangle. Just be careful with it. So that's possible. So just be aware of that. That could come up. This one is nice. And then the height of our whole shape has to be, class? 8 meters. I think that says 8. So 8 meters, right? Height of our prism. All right, now it's just punch it out. Actually, this one you can do in your head. Oops, I never got my height in there. You know, I looked and I saw I didn't have meters, meters, meters. I got to get my height in there. All right. Yeah, you can do this in your head. So half of a 4 is 2. 2 times 5 is 10, and 10 times 8 is 80, and we got 80 meters cubed. You could get 80 meter by meter by meter cubes inside of that prism, or that tent. All right, whatever. Yes? Yeah, the number 7 has no value. Okay, that's why. I wasn't even paying attention to my 7. Look, remember, here's a base. Here's a base. What is the height? The perpendicular distance between those bases. This 7 is just one of the sides of the triangle. Actually, that would have been here or there. And we don't use it. We don't need it. It's of no value. It is of no value. It's non-consequential, Lauren.
If we would have put volume for a cylinder instead of like for Prism, would that have affected our answer?
Only if you would have used area of a triangle for the base of your cylinder. Because again, you know, area of a cylinder, cylinders have round bases, but as long as you still used area of a triangle, you'd have ended up with the right volume, and you'd have been fine as long as you realized it was a triangular base. But it's simple. Cylinders have round bases. Everything else is a prism. So at least when there's two bases. You'll see tomorrow we're going to do pyramids and cones. You guys kind of know what a pyramid and a cone is. So if it's three-dimensional, at least the ones we're dealing with, circular bases is a cylinder, and triangular bases is a prism. All right, last one. What happened to my dotted lines? Oh, because I didn't draw this one. Okay, so I don't know if you can picture this three-dimensionally, but this is a prism, and we are going to use the formula volume of a prism equals what kind of shape is our base? Wyatt? It is a trapezoid. So can somebody give me the trapezoid? Well, I already wrote, yeah. So we want area of a trap. We'll get the other part in a minute. Times height of the whole shape, right? Area of the base times the height. Okay, now let's go through and write the trapezoid formula. Nick, area trapezoid. Correct. 1/2 times the quantity, so parentheses, base 1 plus base 2 times the height of the base. And then don't forget, times the height of the whole shape. What do you think is the probability of a student forgetting that last H? High or low? High. What about a careless, sloppy individual? Real high, you sloppy, careless people. Really high. You're going to forget that last H, and you're not going to get it right. I'll tell you what, though, if you do put the units in, you should be able to catch your mistake and realize you don't have cubic units. But then you careless, sloppy people don't put units in either, do you? So you don't even get help there. But be careful. With the color, it's easy because it's obvious. But if you're just going black and white, then you've got to be careful. All right, go ahead and try it. See if you can get it. I'm going to pause the video. I know I am. I'm frozen in place. On 3, the answer is 1, 2, 3. Awesome. 132 units cubed. Hey, volumes aren't hard. Volumes are not hard. Remember, you got to do what's in the parentheses first. So you got to do the 7 and the 4 and get 11. I did the intermediate step. You don't necessarily have to show this step as long as you're here. But just be careful with your calculator there, right? Just be careful with your calculator there. Any questions? All right, you got about 12 minutes left. Good time to get started on your homework. I didn't give you a ton, so pay attention. I want quality tonight, all right? Give me quality. Sam. Yes, sir.